Hey everyone, welcome to SmartFarm documentary. Across the sun-drenched fields of Georgia, Alabama, Texas, and other southern states, peanut plants stretch low across sandy soil. At first glance, they seem modest, but beneath the surface, hidden underground, millions of pods are forming, making the United States one of the world's leading peanut producers. Each year, American farmers harvest more than 1.5 million tons of peanuts. These peanuts fuel a multi-billion-dollar industry supplying domestic food manufacturers and global markets alike. From peanut butter and roasted snacks to cooking oil and livestock feed, peanuts are deeply embedded in modern food systems. But behind every jar of peanut butter lies months of soil preparation, precision, planting, careful irrigation, mechanized harvesting, and advanced processing technology. Today, we follow the complete journey of American peanuts from field to finished product. Peanut farming begins in spring, typically between April and June, when soil temperatures are warm enough to ensure uniform germination. Peanuts require loose, sandy, well-drained soil because the pods develop underground. Before planting, farmers deeply till the soil to break compaction and improve aeration. Ideal soil pH ranges from 5.8 to 6.5. Lime may be applied to adjust acidity and improve calcium availability. A critical element for proper pod development. Crop rotation plays a vital role. Fields previously planted with other legumes or crops like corn help reduce disease pressure and improve nitrogen balance. Rotating crops also disrupts pest cycles. Modern peanut planters ensure accurate seed placement. Seeds are planted about 2 to 3 inches deep, spaced 3 to 4 inches apart within rows that are 36 to 48 inches wide. Precision planters equipped with seed meters maintain uniform spacing and reduce seed waste. Once planted, irrigation management becomes essential. Peanuts are sensitive to water stress, especially during flowering and pod formation. Drip irrigation or center pivot systems deliver controlled moisture while preventing waterlogging. Weed control is critical in early growth stages. Mechanical cultivation and selective herbicides prevent competition for nutrients and sunlight. About 30 to 40 days after planting, peanut plants begin flowering. Pale yellow flowers bloom above ground, but the fertilized ovary grows downward into the soil in a unique process called pegging. The peg penetrates the soil surface, and pods develop underground, a characteristic exclusive to peanuts. Peanuts are typically ready for harvest 120 to 150 days after planting. Determining the right harvest window is crucial. Farmers examine pod maturity by checking the inner shell color and kernel development. Harvesting begins with specialized digger-inverter machines. These machines cut the taproot beneath the plant, lift the entire plant, and flip it upside down so pods are exposed to air. The vines are laid in windrows across the field. For several days, usually 3 to 7 depending on weather conditions, peanuts dry naturally in the field. Moisture levels must drop from around 35 to 50% at harvest to below 10% for safe storage. If weather conditions are humid, mechanical dryers may be used to prevent mold development. Once dried, combine harvesters move through the windrows, separating pods from vines. Modern peanut combines can cover several hectares per day, significantly reducing labor demands. The harvested peanuts are loaded into trailers and transported to buying stations or processing plants. From here, the industrial journey begins. At the buying point, peanuts are weighed and graded. Moisture content, foreign material percentage, and kernel quality directly influence market price. Peanuts are cleaned using vibrating screens and air blowers to remove soil, plant debris, and foreign objects. Depending on their final destination, peanuts are routed to different processing lines. For peanut butter production, peanuts first enter roasting machines. High-pressure roasters evenly heat the kernels to enhance flavor and reduce moisture. Precise temperature control ensures consistent roasting. After roasting, blanching machines remove the thin red skin through suction and abrasion systems. The clean kernels are then ground in industrial grinders. Additives such as salt, sugar, or stabilizers may be introduced depending on product specifications. Grinding plates reduce peanuts into smooth paste or leave small chunks for crunchy varieties. The finished peanut butter flows through piping systems into automated filling lines. Jars are filled, sealed, labeled, and packed for distribution. For snack peanuts, roasting and flavor coating systems are used. After roasting, peanuts pass through seasoning drums where salt, honey, barbecue spices, or other flavorings are applied evenly. A secondary drying stage ensures seasoning adhesion and crisp texture. Peanut oil production follows another industrial pathway. Cleaned peanuts are dried to optimal moisture levels before entering oil press machines. High temperature and pressure extract crude oil. The crude oil passes through filtration, refining, and deodorization stages to improve clarity, flavor, and shelf life. Final packaging occurs in automated hygienic bottling systems. Peanut byproducts, including peanut cake after oil extraction, are used as high-protein animal feed, ensuring minimal waste. Peanuts reach consumers in multiple forms. Peanut butter remains one of the most popular spreads worldwide. It is a staple in households, bakeries, and food manufacturing. Roasted and flavored peanuts serve snack markets. Peanut oil is valued for its high smoke point and mild flavor, widely used in cooking and food processing. Ground peanuts are used in confectionery sauces and protein supplements. Peanuts are rich in plant protein, healthy fats, vitamin E, magnesium, and antioxidants. Their nutritional profile supports heart health and energy production. From raw kernel to refined oil, peanuts demonstrate remarkable versatility. The peanut industry supports thousands of farmers, machinery operators, processing plant technicians, quality inspectors, food scientists, and logistics professionals. States like Georgia, the leading peanut producer, depend heavily on peanut farming for rural economic stability. Advanced mechanization has increased efficiency and reduced labor intensity. But human expertise remains central to crop management, harvest timing, and quality control. Research institutions continuously develop improved peanut varieties with higher yields, stronger disease resistance, and better oil content. Peanuts are more than an agricultural commodity. They represent innovation, resilience, and economic integration within global food systems. The journey of a peanut begins in warm spring soil and unfolds through months of careful cultivation. It grows underground through a unique pegging process. It is harvested with precision machinery, dried under controlled conditions, cleaned, roasted, pressed, and transformed into products found in kitchens around the world. What appears to be a simple nut is in reality the product of coordinated agriculture, industrial engineering, and global trade networks. The next time you spread peanut butter on bread or cook with peanut oil, remember that each serving reflects months of effort from American fields to modern factories delivering nutrition and flavor to millions worldwide.